Welcome back. My name is Satyajeet Sahu, and today we are going to solve some objectives on soil mechanics for your upcoming HPCL examination. Okay, for your upcoming HPCL examination, today we are going to solve some objectives from your soil mechanics. So which topics we'll cover today? We will cover the basic properties of soil, we'll cover index properties, we'll cover classification of soil, and we'll cover effective stress, and we'll also cover permeability and seepage. So these topics we are going to cover today, and we'll be solving lot of numericals. Okay, so welcome all the participants who are watching the lecture, and these objectives which I told, these objectives will also be helpful. These objectives will also be helpful for your GATE 1 mark. Welcome Karthik, welcome Satish, welcome Samriddhi. So these objectives will also be helpful for your GATE 1 mark, yes, for your SSC JE, okay, and also the state engineering services, okay. State engineering services also, these objectives will be very helpful. So we are having this HPCL series, but the objectives will be same for other examinations also, right? Just because they're asked in the HPCL examination, that doesn't mean that they will not ask in the other exams, okay? So in this particular lecture series, first of all, today we are going to see what? We are going to see soil mechanics objective. Then on 21st July, we'll be solving objectives on what? Consolidation, compaction and shear strength. And on 23rd of July, we'll be seeing what? Foundation engineering. In that, we'll cover bearing capacity, pile foundation, and then earth pressure, stability of slopes. Okay, all those topics we'll cover there. Okay, so let us start the lecture. But before that, a short introduction about myself. My name is Satyajeet Sahu. I have done my BTech and MTech from IIT Kharagpur. I have been selected into many of the PSUs, and I was selected into HPCL also. So I can guide you better also. Yes. So I was selected to HPCL through GATE. Okay, that time HPCL took from GATE. Okay, so this time they're conducting their own examination. So I was selected into HPCL, IOCL, DMRC and RITES. I have more than 10 years of experience in teaching for GATE and ESE field, and I have taught in more than 15 states, and I teach all the civil engineering subjects and general studies. So let us start this objective series, okay? So here I will be giving you the questions. You read the question and answer it correctly, and then at the end, means at the end of every question, I'll discuss the answer also. So let us start. So hope you all are ready. Okay, so please bring your pen and paper. Calculator won't be required that much. I will also see your comments here. Okay. So calculator won't be required that much because they are mostly what? Straightforward questions. But I expect that use your calculator also if there is some numerical. Let us start the question. The first question, which of the following is not a possible value of porosity? So please write in the comment section the answer. Please write in the comment section. Which of the following is not a possible value of porosity? Mark the words, it is not a possible, means which cannot be the value of porosity. Yes, the answer is D. Yes, the answer is D. Porosity is what? Porosity is the volume of voids divided by total volume. Now you see the volume of voids will always be less than total volume, right? It cannot be equal. It cannot be equal. It has to be less. If it has to be less, porosity has to be less than what? 1. So it cannot be 1. Correct answer. Let us solve the next question. So we have 50 questions like this today. So hope you will enjoy today's session. We have 50 questions, okay? 50 questions. So let us start. The second question. So liquid limit is given, plastic limit is given, shrinkage limit is given, the natural water content is given, and they have asked you soil is in which state. Okay, soil is in which state? Please answer this question. Please answer this question. Sriyas has answered 1. Others? What is the answer? Monica answered A. Okay. Others? Mukula answered A. Yes, correct. You see, if we draw volume versus your water content, then we get a curve like this, right? And we know this is your shrinkage limit, this is your plastic limit, and this is your liquid limit. If the water content is above liquid limit, we'll call the soil to be in liquid state. Between plastic and liquid, we'll call this as plastic, okay? And solid, shrinkage and plastic, I will call it as semi-solid, and below shrinkage limit, I will call this as solid. Now, in this question, if you see, the liquid limit is given 50%, plastic limit is given 30%, and shrinkage limit is given 12%. And your water content is somewhere here, 23%, right? So it is lying between what? Your shrinkage and plastic. So this is what? Semi-solid. So such type of objectives they ask a lot in your HPCL or any PSU examination or SSC JEE or GATE 1 mark. Let us solve the next question. Hope you are enjoying the lecture. Okay, the range of particles is denoted by what? The range of particles is denoted by what? The range of particles is denoted by what? Okay, somebody has answered C. Karthik has answered C. Vivek, Saurabh, Sri. Very good, very good. Yes, this is the range of particles. Okay. D60 by D10. What is the other name to this? The other name to this is also coefficient of what? Coefficient of uniformity, right? The other name to this is coefficient of uniformity, okay? And this is also equal to what? The range of particles. The range of particles, okay? The range of particles, okay? What was D60? D60 is the size such that 60% are finer than that, right? And D10 is what? Size such that 10% are finer than that. Let us solve the next question. So please solve this question. Good morning, Rajashree. Good morning, animated gift. Okay. Good morning, Anjanelu. Okay. Welcome, Survey. So answer this question. 1/4 of soil mass volume is voids. Okay. 1/4 of soil mass volume is voids. The void ratio is. Yeah, these are numerical, some objective sessions for HPCL. Okay, objective sessions for HPCL. So some numericals will be there, some theoretical questions will be there. All types of questions we are trying to cover. What is written? 1/4 of the volume void mass is void. That means what? Volume of voids is equal to 1/4 of total volume. Now what is void ratio? Void ratio is volume of voids by volume of solids. Now see, if volume of voids is 1/4, volume of solids will be how much? 3/4, the remaining one? Yes. So from here I can write down 1/4 of the total volume, 3/4 the total volume, that is equal to how much? 1/3, that is answer D. You see, all these questions can be solved by just knowing the basic definition and the basic formulas. Okay, let us solve another question. Void ratio of soil is 0.4. Porosity will be, it's a very straightforward question. Okay, please answer fast. Void ratio of soil is 0.4. Porosity will be. Samridhi answered C, yes. So use this formula. Porosity is equal to E by 1 plus E, right? So this becomes, you see, 0.4 by 1.4. That I can say 4 by 14, or I can say 2 by 7. So right answer is C. Let us solve a more tricky question. Question number 6. Okay. Let us see how many are able to answer this question. Okay, so it's a plasticity chart. Yes, So in plasticity chart, we plot between what? The liquid limit and the IP, yes, plasticity index. So this zone X, what we call this zone? What is this zone? So they will ask you like these questions. Please answer this. Okay, some people have answered also. Yes, it is C. You see, above 50 we call this as what? High plastic. 35 to 50 we call this as intermediate plastic. And below 35 we call this as low plastic. Now, this is the A line, right? Below A line we call this as silt, and above A line we call this as clay. So you see, this X is what? This X is what? It is high plastic and it is also silt. Yes? So I can say this is what? High plastic silt. I am writing Y. Tell me what is Y? Tell me what is Y. Answer in the comment section. What is Y? What I will tell Y? Please write in the comment section what I will tell Y. Means write the name, write the name, write the name, write the name. Okay, you have written the name. Very good. It is intermediate plastic clay. Very good, very good, very good. You see, you are able to answer the questions. Okay, very good. Let us solve next question. Seventh question. Sand has uniformity coefficient of 5. Okay, and D30 square is equal to 2 times of D60 into D10. The sand is, we have to classify the sand based on this. You have to classify the sand based on this. Let us answer this question. This is what? Cu is given 5. Okay. And then D30 square is equal to given twice of D60 into D10. Okay. Now please answer this question. Sand is what? What is sand? Akang Sinha has answered A. Okay. Answered A. Others? Others? A. Very good. You see, it is sand. And this coefficient of uniformity is greater than 4. So the first criteria is satisfied. Now you see, we know Cc is equal to how much? D30 square by D60 into D10. Now you see, this D30 square is given 2 times of D60 into D10. So if you put this relationship, what happened? Your Cc is coming 2, which is less than 3 and greater than 1. This is the condition, right? So you see, your Cc is within the range and your Cu is greater than 4 for sand. So it is a well-graded sand. If suppose this Cu was, suppose this Cu was 3, then the answer would have been what? Tell me. Suppose the Cu is 3, the answer would have been what? Tell me. If it was 3, the answer would have been what? Tell me. If it was 3. It's not 3. If it was 3. Yeah, see, this is less than 4, then poorly graded. Remember this condition that both the condition has to be satisfied, not only one. So Cc has to be within 3 and 1 and Cu has to be greater than 4. So it is not only one condition satisfaction. Both the conditions should be satisfied, then only I can say this. Let us solve the next question. Okay, so boropit has come into picture. So it's a numerical, kindly solve this. It's a numerical, kindly solve this, okay? But this numerical can be solved within, 1 minute or half a minute also. So please solve. In a boropit, the void ratio is 0.5, okay? So we have this boropit, okay? Here, the void ratio is 0.5. Soil excavated was compacted into a fill, okay? In some fill it was compacted and the void ratio there was 0.3. See, if 150 was excavated from the borrow pit, okay, the volume of the fill. So this volume you have to find out. You can take this as 1, 1, this as 2, 2. We know this relationship, right? V1 by V2 is equal to 1 plus E1 by 1 plus E2, right? So from this we can easily solve. You see, I can write down now 150 by V2 is equal to 1.5 by 1.3. So this get cancelled. I get 100. From here V2 is equal to how much? I am getting 130 meter cube. So they can ask you some short numerical like this also. They can ask you some short numerical like this also. Please solve this next question. Okay. So we have classification of soil now. And classification of fine-grained soil. Okay. Classification of fine-grained soil. The liquid limit is given to us. Okay. And then the plastic limit is given to us. Okay. So what to do? Solve this. Okay. Again B. Okay, you're telling the previous question or this question? This is not B. This answer is not B. See, when they're asking you fine-grained soil, first you find out your IP. IP is how much? 21. Then to find out IP of A line. IP of A line is what? 0.73 liquid limit minus 20. Now first of all you see this liquid limit is within what? It is within your 50 and 35. That means it is intermediate. So only one option is there, right? You need not check also, right? Yes, you have to be a little smart, right? You see, it is intermediate, right? In intermediate, only one option is there. So was there any requirement to check? There was no requirement to check, right? But suppose you want to check also, how much is IP of A line? How much is IP of A line you are getting? I think 20.44, right? Let me calculate. You will be getting 20.44, I think, something like that, right? Please calculate and tell me. Put here 48. What is IP of A line? Nobody is telling, I will only tell. So 28 into 0.73, I am getting 20.44. You see, your IP is greater than IP of A line. That means what? It lies above the A line. Above the A line means what? It's clay. But there was no requirement. There was no requirement to check that it is clay or not. Why? Because there was only one option with intermediate. You can solve this without, checking that. But suppose there was other option for intermediate also. Suppose there was option of MI. Then you have to check this condition, right? You have to find out IP and then IP of A line and compare. Okay? So let us solve the next question. The next question is, okay, permeability of the soil. So we have come to permeability now. So permeability of the soil decreases with increase in temperature, increase in organic content, or increase in void ratio, increase in unit weight of soil. What is the answer? It's an objective question from a permeability. So 10 questions we have solved, okay? In next we have more 40 questions to go. Come on, fast. We have more 40 questions to solve. Naman is answering B, no. Yes, it is correct. I think multiple answer is correct. I think both B and C are correct. Yes or no? I think both B and C are correct, right? Yes. You see, K is directly proportional to E cube by 1 plus E, right? No. So if E increases, then K also increases. So this is wrong, okay? Now, your K is what? Inversely proportional to your viscosity. And your viscosity is inversely proportional to temperature. So K becomes directly proportional to temperature. So if your temperature increases, your K will also increase. So this is also wrong. But if the organic content increases, then what will happen? There will be blockage, okay, because organic content has less specific gravity, and therefore there will be increase in organic content. The permeability of soil will decrease. Now D will not be a correct answer. Why? Because it is not written water, it is written what? Soil. If it was water, then it would have been right answer. Right? Very good. Let us solve the next question. Please solve this. In an anisotropic soil, horizontal dimensions are transformed by multiplying original dimensions with. Okay, what is the right answer? Let us see. So we know that in your anisotropic soil, we cannot directly apply the equations of, flow net. So there we transform the section, right? And we know that vertical dimension doesn't transform. Yes, vertical dimension don't transform. Okay, vertical dimension don't transform. Okay, but horizontal dimension transform. Suppose we have a rectangle like this. So in the transform section, what will happen? The vertical depth will remain same. But suppose this is B. This will become how much? This will become B into kz by kx square root. Right? To remember this thing, okay? You have to remember this thing. This is what? Kz by kx square root. So suppose I am telling kz is what? Vertical, and x is what? Your horizontal. See, sometimes they will write you ky by kx square root. That is also same. Because that depends on which one you have taken vertical. You have taken vertical as the y or your z. Okay? That depends on that. Okay? Now, like they can ask a question like this. Okay? If suppose this originally this was 10 mm. Suppose originally 10 mm. And I am saying that kz is equal to 4 times of kx. Now tell me, in this transformed section, what will be this horizontal dimension? In the transformed section, what will be this horizontal dimension? Please write down the answer. In the transformed section, what will be this horizontal dimension? Please write the answer. They might ask you directly this, or they might ask you objective also, like this, numerical. So if this is the case, it will be 10 into root under kx, kz, which is 4 times kx, divided by what? Kx, the square root of 2, that is how much? 20 mm. Understood? Understood? Very good. So they can ask you questions like this. Let us solve the next question. Okay, very commonly asked question. The seepage velocity of soil is related to discharge velocity. How? Write down the answer. How it is related? Write down the answer. A. Yes, it is always greater than the discharge velocity. You see, the seepage velocity is what? The discharge velocity divided by porosity. And we have seen previously that porosity is what? Always less than 1. If this porosity is always less than 1, that means what will happen? This seepage velocity will always be greater than the discharge velocity. It is not sometimes. It is not sometimes, it's always. So next question. NF by ND. What is NF? The number of flow channels, and then ND is the number of potential drops. This in a flow net depends on what? Okay, this depends on what? Write down the answer. So we are solving questions for your HPCL, but they will be applicable to all the kinds of PSU exams or SSC. In SSC prelims also you can expect this kind of answer. Yes, this only depends on the boundary condition. Very important point, that NF by ND, this is also known as safe factor, right? This is also known as safe factor. In exams they might ask you this, safe factor. it depends only on the boundary condition, doesn't depend on the head difference or the type of soil. Let us solve the next question. Okay, critical hydraulic gradient. Please answer this question. Please answer this question. You should know how to find out critical hydraulic gradient. We know the formula. Use that formula and find out this. The porosity, the void ratio is given to us. You have to establish a relationship. Just do some, cross multiplications. You'll get the answer. Yes, it is D. Okay, let us see. The critical hydraulic gradient is what? G minus 1 by what? 1 plus E. Now, E is 0.5. This becomes G minus 1 by 1.5. So, here it will be 1.5 I is equal to G minus 1. If you take this 1 this side and this side, it will be 1 is equal to G minus 1.5 I. So, this is the right answer. Hope you are enjoying the lecture. Let us solve next question. The space between two adjacent flow lines is known as. The space between two adjacent flow lines is known as. The space between two adjacent flow lines is known as. Yes, it is flow channel. You see, these are the flow lines, right? These are the flow lines. So, the space between two adjacent flow lines, this is known as what? A flow channel. So, there will be multiple flow channels like this. Now, if I ask you, the space between two adjacent flow lines and two adjacent equipotential lines, means this one. This is what? Space between two adjacent flow lines and two adjacent, these are flow lines, and this is equipotential lines. This will be known as what? Tell me. This is known as what? The space between two adjacent flow lines and two adjacent equipotential lines. We call this as what? Tell me. What will be the answer for this? No, this is not the flow net. This overall thing is flow net. But what is this thing which I have highlighted? This is flow field. Okay, this is what? Flow field. You see this total one is flow net. Okay, and you see this one thing, these are flow channels. Yes, the total one is flow net. This one channel means what? The space between two consecutive, or we can say adjacent flow lines, is what? Your flow channel. But if you consider the space between two adjacent flow lines and two adjacent equipotential line, that is what? Your flow field. So they can ask you this question also. Let us solve the next question. Okay. Quicksand condition is commonly found where? Quicksand condition is commonly found where? Answer D. Very good. It is found in silty sand. It is found in silty sand. See, it is not found in gravel. Okay. It is found in sand, and in sand I can say silty sand. It is not even found in clay. It is not found in clay. Now what happens in quicksand condition? In quicksand condition, the effective stress is 0. So effective stress is 0 and shear strength equation is what? It is effective stress 10 phi plus C. Now in sand, silty sand, what happens? Your C is 0. If C is 0, then shear strength is 0, right? Okay. But in your clay, what happens? You see, even if your effective stress is 0, C is non-zero. So shear strength also will be non-zero. So we don't find this what? Quicksand condition in clays. We only find in what? Silty sand. Remember this. Okay. Remember this. We only find in what? Silty sand. Next question. The effective stress at the depth below water table increases on. Okay. Answer this. What will increase the effective stress? What will increase the effective stress? Placement of surcharge, lowering of water table, both of them or none? Which will increase the effective stress? Yes, the answer is C. See, if you place surcharge at the ground level, the effective stress increases everywhere by plus Q, right? Okay, everywhere it increases by plus Q. So yes, the first one is correct. And if you lower the water table, what will happen? If you lower the water table, the pore water pressure decreases. If pore water pressure decreases, what will happen? Your effective stress will increase. The answer is C. Next question. Okay, little tricky question. Please solve this. It's a little tricky question. You can answer it very easily. See, it's written the permeability of both layers is same. So if we have two layers, okay, one is H, okay, and one is 2H. One is H, one is 2H. But the permeability is same. If permeability is same, it is only one soil layer, na? If permeability is same, it is only one soil layer, na? With what? Your coefficient of permeability K. Yes. So in horizontal also it will be K, in vertical also it will be K. So answer is what? The ratio is 1. So it's a tricky question. It's a tricky question. Understood, everyone? That since it is given both the layers have same K, that means what? It is one layer only. That was a trick question. Let us solve the next question. Okay, arrange this following. Okay, kaolinite, illite and montmolonite in the decreasing order of swelling capacity. In decreasing order of swelling capacity. Okay, these are clay minerals. So which of these has maximum swelling capacity? That will be first, then second, then third. Okay, so decreasing order of swelling capacity. Somebody answered C. Okay. MIK, Akshay Shukla. Saurabh Hanipaj answered B. Bijita answered C. Rajasthi has B. So there are B, alternative things going on. Okay, so people are confused. The answer is C. Remember that montmolonite has the highest swelling capacity, then I and then K. Okay, next question. Okay, this is a very straightforward question. Please answer this very fast. It's a very straightforward question. Answer this very fast. Very straightforward question. Answer this very fast. Transported due to gravity. What we call this type of soil? Transported due to gravity. What we call this type of soil? Yes, Rasmita has answered correctly. It is talus. You have to remember the names, okay? Nothing else. It's just memory based question. The next question. Okay. Some numerical. Consistency index. Liquid limit is given. Plastic limit is given. Water content is given. They've asked you what? The consistency index. Please find out the answer. Consistency index. Consistency index, denominator will be IP. Numerator is what? It is your normal water content or water content minus your liquid limit. Not liquid limit. Sorry, liquid limit minus the water content. Natural water content. So please find out this answer. What is the correct answer for this? Okay, B. Very good. Liquid limit is how much? 30, sorry, 50. Water content is 35. Okay. Then IP is what? Liquid limit minus plastic limit. So we're getting 15 by 20. This is in decimal. If you multiply 100, get in percentage. So this is 3 by 4. It is how much? 75%. Correct. Let us solve the next question. Okay, okay. Toughness index. Let us solve. Sorry. Solve this question. Toughness index. I'll give a small tip here. Remember toughness index, you see your consistency index is your liquid limit minus your water content divided by IP. Your liquid index is water content minus plastic limit by IP. Okay. In your toughness index, this IP will be numerator and then your flow index will be in denominator. Always remember this. You see here and here it is in denominator, here it is in numerator. So you see your plasticity index is how much? 45 minus 20. Liquid limit minus your plastic limit is how much? 25. And your flow index is how much? Flow index is nothing but the slope of, right? The slope of your semi-logarithmic graph of what? Your water content and number of flows in determination of liquid limit, right? So the flow index is what? 10. Now you see this is in decimal. In percentage you have to multiply 100. So answer is how much? 250%. So I gave this question because we don't find so much questions in what? In your toughness index, right? You don't find so much questions in toughness index and there is a good chance that they might ask you in the examination and you do some mistake. Next question. If air content of a soil man is 34%, find the degree of saturation. If air content is 34%, find the degree of saturation. Okay, somebody has answered correctly. Akshay, I think, has answered first. Others also please contribute fast. Yes, it's very easy. See, air content plus your degree of saturation will be 100%. Remember this thing, okay? So now your degree of saturation will be how much? 100 minus air content, that is equal to 100 minus 34, giving me how much? 66. You see, all this is a very straightforward questions, but yes, we miss this question in the examination because we might not be knowing the basic formulas. Let us solve the next question. Okay, so here after 23rd, 24th. Okay, so we are almost reaching halfway. We are almost reaching the halfway of the numericals. We have solved almost 24 questions. Please solve this question. Okay, little tricky. I'll solve for you, don't worry. Try it out. So we have this 600 micron and we have this 500 micron. So below this, how many passed? Below 600 passed is 300. It is 300 passed. Below this is how much? 50 gram passed. And total is how much? Total is your 500 gram. Now tell me this 300 gram. This 300 gram is what? Rajesh answered. This 300 gram is actually 300 by 500 into 100, that is how much? 60%, right? So if 60% is passing through some size, that is known as what? If 60% is passing through some size, that is known as what? Tell me. Now tell me, what is this size? What is this size? Tell me. What is this size? What is this size then? What will call this? What will call this? 60% is passing through this. What we will call this? Somebody adding insufficient data. This is D60. This is D60. Now see, 50 gram is what? 50 gram is 50 by 500 into 100. That is equal to how much? That is equal to 10%, right? That means this 500 micron is what? Tell me. This 500 micron is what? This 500 micron is what? It is D10. You see, now D60 by D10 is how much you're getting? 600 by 500, that is equal to 1.2. Now it is a sand, right? And this D60 by D10 is your coefficient of uniformity is coming less than 4. If it is less than 4, that means what? It is indirectly poorly graded, right? It is indirectly poorly graded. There was no need to check the other one. CC data is not there. But in CU only it is coming less than 4. That means what? It is poorly graded. Everybody understood this question? You see in this question, so many objective questions I tried to cover, right? Yes. Let us solve the next question. Okay, please solve this question. Okay, A. Somebody answered A. Okay. Others? A. Very good. Very good. Degree of saturation can be equal to 1. Yes, but cannot be greater than 1. Why? Degree of saturation is volume of water by volume of voids. Now, volume of water can be equal to volume of voids. That means degree of saturation can be 1, but can never be greater than 1. Okay? And greater than equal to 0. When it will be 0, tell me. When it will be 0? When it will be 0? When it is 0? When it is 0? When the degree of saturation is 0? Dry soil, very good. And when the degree of saturation is 1? When the degree of saturation is 1? When the degree of saturation is 1? Saturated soil, very good. Okay, saturated soil, very good. Fully saturated, very good. Better word. Okay, better word. Next question. So 25 questions we solved. Okay, so 25 questions we solved in what? In almost half an hour, 40 minutes. So tell me, is the coverage of questions good or not? Okay, is the coverage of questions good or not? Are you happy that your concepts are getting revised, right? So are you happy that your concepts are getting revised? I've designed all these things myself only so that most of the objective questions which are asked in the examinations are covered very nicely. Okay, so solve this very straightforward question. Please solve this very straightforward question. Solve this. High plastic inorganic clay. High plastic inorganic clay. What we call that? High plastic inorganic clay. See, high plastic means H. Inorganic clay means what? Your C. So CH. We write reverse, right? So we write reverse. Yes. Suppose it was high plastic organic clay. If it is in high plastic organic clay, then what would have been the answer? If it was high plastic organic clay, then what would have been the answer? Tell me. If it was high plastic organic clay, what would have been the answer? Tell me. High plastic organic clay. OH. Very good. Okay, this is H. Organic clay is your O. Inorganic clay is your C. And silt is M. Silt is M. Very good. Next question. Okay, answer this question. Very easy question, straightforward question. Very easy question, straightforward question. About unit weights. Remember this, gamma D is equal to gamma T by 1 plus water content. If saturated, then gamma D is equal to gamma saturated by 1 plus water content. The water content has to be in what? In your decimal. So what's the answer for this? Very simple. What's the answer for this? Very simple. Yes, 15. 18 by 1.2. That is equal to what? 15. Okay. So many students might be thinking, sir, why we are solving very straightforward and simple questions? See, in the GATE examination, in the HPCL examination or SSCJ or PSU examinations, okay, in SSC prelims, not in mains, we expect this kind of questions. Okay. See, for your GATE examination, right, and for ESC examination, in the evening I am conducting classes. Okay, in the evening I am taking YouTube classes for the same, but this session is targeted towards what? It is targeted towards your HPCL and other PSU examinations. Now understand that the syllabus is same for all examination. See, syllabus is same, but when you are preparing for a certain examination, what you have to do? You have to reorient your mind. Yes, you need to solve questions which type are asked in that particular examination. See, syllabus is same, the formula and all is same, right? But the types of questions will be different, and therefore we are conducting different sessions. Okay, so you see, for GATE and all, I am conducting evening sessions. The monsoon series we are going on. Okay, other faculty also taking the monsoon series, right? And we have this HPCL series, which is targeted toward HPCL and PSU examination, so that you get an idea of what type of questions will be asked in both GATE and other examinations. Okay. Let us solve the next question. Okay, the void ratio changed from 0.4 to 0.6% increase in the volume. The void ratio changed from 0.4 to 0.6, the percentage increase in the volume. And if you are liking the video, then please like the video and mention some good comments in the comment section. If you have doubts also, you can answer that. You can ask those doubts in the comment section. I will answer those doubts also in the comment section. Okay. 50%. C, 14.3%. Very good. Deepak, Saket and Rajastri and Vivek. You see, we know that total volume is what? Volume of solids into 1 plus E. Now you see, when there is volume change, the void ratio changes, but the volume of solid will not change, right? So first volume will be how much? Volume of solid into what? 1.4. Yes, the final volume will be volume of solids into what? 1 plus it is 1.6. So percentage increase in volume will be how much? This will be your V2 minus V1 by V1 into 100, right? You see, your V2 minus V1, that is 1.6 Vs minus 1.4 Vs divided by what? 1.4 Vs into 100. That is equal to how much? I can say 0.2 Vs by 1.4 Vs. The volume of solids don't change when the total volume change. So using this concept, we can solve. You're getting how much? I can say 200 by 14, or I can say 100 by 7. That is how much you're getting? This is 14.3%. This is what? 14.3%. Okay. So this is the right answer. You can see, you can solve this type of questions by using the basic concept that what? That total volume is this, and volume of solids don't change even if the total volume change or your void ratio change. Solve this next question. Interesting question. Many statements, you have to answer the correct statement. You have to answer the correct statement. Computer science session is also going on, okay, in HPCL series, or computer science session is also going on. You can follow that, okay. You can see in our YouTube channel there are sessions for computer science also. Please once go through the different videos, okay. Okay, Ayush is answering C and Karthik is answering D. Others, Hanif is answering D. Others, Samriddhi D. Very good. See, degree of saturation cannot be more than 100%. Wrong. Submerged unit weight is more than dry unit weight. No, it is less than that. Submerged is the minimum one. Okay. Submerged is the minimum one. Remember this. Okay. So this is wrong. dry soil is not a three-phase system, it is a two-phase system. And submerged unit weight is less than saturated. Yes, it is correct. Very good. And anyhow, submerged unit weight is what? Is equal to saturated minus gamma W. So obviously it will be less. Next question. Okay. Little interesting question. Little interesting question. Let us see how many solve this correctly. It is interesting question. Okay. Let us see how many solve this question correctly. So we have solved 30 questions. Bravo. Bravo. And you see, as we have started solving questions, the speed increased, right? Initially, we were able to solve less. But as we are solving more questions now, we are able to solve more, okay? The speed has increased. So you see, practice makes a man and woman both perfect. That is true. That is true. I'll give this hint. See, this is English channel, so mostly I am taking in English. Okay, इसीलिए थोड़ा हिंदी भी बोल देते हैं, आप रिक्वेस्ट कर रहे हैं तो. Okay. Somebody answering D. Rajastri C. Okay, okay. You see, use this relationship. If you see the first one, it's written two-phase system. See, two-phase system, water content has to be, two-phase system, either it will be dry or saturated, right? Yes, either it will be dry or saturated. Now see, water content is given some value. It is not 0. That means it is saturated, right? Yet, you see, it cannot be dry because water content is given. If water content is given, it is not dry, I mean saturated or fully saturated, I can say. So fully saturated होगा तो क्या होगा? S will be equal to 1. So in this equation, you see, if S is 1, okay, and suppose you are putting first or second condition, E is half of G. So E is half of G and S is 1. So what is happening to water content? You see, the water content is coming how much? Water content is coming 0.5. This is in decimal. In percentage, it will be 50%. You see, the answer is what? B. Understood this question or not? Little tricky. Yes, it was little tricky, right? It was little tricky, right? That directly they have not given what? How none of this? How none of this? You see, void ratio is 0.5 times of G. So you see, this relationship holds, right? So you see, the B condition is getting satisfied. Understood or not? Any doubt in this question? Any doubt in this question? अब मत बोलना कि फिर से बताओ. Doubt क्या है बताओ? Doubt तो नहीं है, ठीक है? Two phase लिखा है तो dry या फिर it will be fully saturated. Water content is given, so fully saturated, right? And then just check this condition. Just check this condition. Okay? Very good. Next question. So direct question. Please answer fast. Direct straightforward question. It is straightforward question. Please answer fast. Upward seepage क्या करता है? Right question. 30 is over 31st. Upward seepage leads to what? Upward seepage leads to what? Somebody is answering B. Upward seepage what? Somebody writing A also. B also. वाह राजश्री वाह, क्या पढ़ाई कर रहे हैं? अरे upward seepage हो रहा है. In upward seepage, what will happen? Effective stress will decrease. That means what? Pore water pressure increase हुआ होगा ना? Yes. So answer is increase of pore water pressure. Yes. Pore water pressure increases and effective stress decreases in upward seepage. And the reverse in downward seepage. In downward seepage, what happens? Or pore water pressure increases and effective stress. Sorry, pore water pressure decreases and effective stress. In downward seepage, pore water pressure decreases and effective stress increases. the reverse. Understood? Okay, next question. Come on. ये क्या है? Capillary action. Please answer this question. Capillary. Capillary action क्या करता है? What capillary action does? Please answer this question. Capillary action, which is capillary saturated, what increases? The answer is both. You see, it becomes capillary saturated. What will happen? The gamma will change to either from dry to saturated, or it will change from bulk to saturated. Yes. If the gamma increases, that means what? Total stress will also increase, right? So you see, the total stress also increases, right? See, above the water, this is soil, suppose, this is soil, and this is your water table. Above the water table, the soil will be either dry or it will be your partially saturated, so bulk unit weight. So if there is capillary action, what will happen? This zone will become now saturated. So what will happen? Sorry. So what will happen? So your gamma will become gamma saturated. So gamma becomes gamma saturated means what? Total stress will increase, effective stress both will increase. So answer is total stress and your effective stress both increases. Next question, 33. Okay. Falling head test. Permeability. Falling head test. Permeability. So 18 questions to go. Come on, fast. Come on, fast. 18 questions to go. So please do attend. Please do attend all these question answer sessions. In very short time, you will be able to revise many concepts. Okay. Okay, somebody answered also. Okay. No. Many people remember the answer. You have not read the question. You have remembered the answer. You see what is written. In T time, now what is K? K is AL by AT into ln H1 to H2. Okay. So you see this is falling head test, permeability test. So if the soil is same, so for the first condition, ALA, it falls in time T, ln H1 to H2. For the second condition, AL, it falls in time 2T, ln H2 to H3. Why? Because it falls from 2 to 3. You see AL get cancelled, AA get cancelled, TT get cancelled, it is 2 is remaining. So what will happen? 2 ln H1 by H2 is equal to ln H2 by H3. So this will become what? Square. So now from here I can write down H1 by H2 square is equal to H2 by H3. So from here what will I get? I'll get, you see, H2 cube is equal to H1 square into H3. So answer is what? Answer is your B. Understood this question? So everybody is answering different question. Everybody is answering different answer, right? Okay, C, right? Okay, C. I wrote something wrongly or what? How it is coming C? Let me say falling head test forms from H1 to H2 in time T, okay, H2 to H3 in time 2T, okay. This answer is B, right? Answer is B, na? Are you getting B or not? Nobody is answering. Yes. See, why you answered A, you know? Because in the normal questions, they give you same time. See, if it is same time, then what will happen? ln H1 by H2 will become ln H2 by H3. So then what will happen? H1 by H2 will be H2 by H3. That is what? H2 square is equal to H1 H3, right? right? So this is when it is same time, but now it is given what? Twice of time, and therefore this 2 will remain, right? Earlier what was happening? Everything was getting cancelled if it is same time, but it is 2 times, so what will happen? This will become 2. So this 2 will go here, okay, and then the square, and then this condition will come into picture. Everybody is clear. So therefore you should read the question carefully. Don't remember everything, right? Don't just mug up everything. Read the question carefully. Next question. Piping. Okay, answer this question. Very straightforward question. Answer this. Permissible hydraulic gradient. Okay. Permissible hydraulic gradient. So IC by I, that permissible one, is equal to your factor of safety, which is given how much? 5. So from here, your permissible hydraulic gradient will be critical hydraulic gradient divided by 5. So what is your critical hydraulic gradient? We have seen earlier formula, G minus 1 by 1 plus E. That is equal to G is 2.7. So 1.7, and then E is 0.7, so 1.7. So your IC is coming 1. So this will be 1 by 5, that is equal to 0.2. First answer. Very straightforward question. Next question. Okay, please answer this question. Soil becomes more permeable. See, that means what? K increases, right? More permeable means what? K increases. K increases on which of these following conditions? K increases in which of the following conditions? More 15-16 questions to go. Come on, fast, fast. A, D, C. K is inversely proportional to surface area. So this is wrong. If we increase the air content, permeability decreases. If we increase organic content, permeability decreases. But if we increasing the degree of saturation, the permeability will increase. Okay, right answer is D. Okay, next. Okay, very straightforward question. We have solved this question before also. Not exactly this question, this concept we have seen earlier. So come on, fast, fast. You should answer this question very fast. Come on, fast, fast. A, seepage velocity is equal to discharge velocity by porosity. Huh? So I can say seepage. Okay. The question is little wrong, right? No, it is. No, it is correct. You see, this is equal to how much? 1 by porosity, which is given 2.5, right? So from here, porosity is how much? 0.4. Now answer this. Now answer this. Why are you taking so much time? Void ratio is what? Porosity by 1 minus porosity. Yeah, you have forgotten all the formulas. Very simple question. I just twisted a bit and you're unable to answer. 0.4 by 0.6, it is what? 2 by 3, answer is 0.67. Forgot formula or what was the problem? Very straightforward questions. Remember this simple formula, okay? Simple, simple formula. You see, in this session, I am making you practice all the basic concepts and all the basic formula in straightforward manner, in twisted manner, everywhere. Okay. Next question. Okay. Classification of soil returns. Classification of soil returns. Please classify the soil. Please classify the soil. It is a good question. It is a good question. Let us see how many answer this question correctly. It's a good question. Classification of soil. This question is a little tricky. I'll solve for you. You see, if you remember our plasticity chart for classification of soil, to remember this chart, okay? You see, this is the A line. This is the A line, right? This A line ends where, tell me? Can somebody tell where the A line intersects this x-axis? Where the A line intersects the x-axis? If you are plotting plasticity chart between what? Your IP and your liquid limit, where this A line intersects, can anybody tell me? Where this A line intersects? The equation of A line is what? 0.73 liquid limit minus 20. So when liquid limit is 20, then it intersects here. Very good. Now you see there was a zone like this. Remember? There was a zone like this where we have what? Dual name. And this dual name was what? CLML. Now you see the question. What is written? Liquid limit is 20. That means what? This is your liquid limit. That means liquid limit is 20. Now you see, this zone was between what? 4 and 7. IP 4 and 7. How much IP you are getting here? Liquid limit minus plastic limit is how much? 5. So if your IP is 5, this is the intersecting point. Tell me, this point lies in that zone, right? So this is what? Your dual name CLML. So remember this question, they have asked once in one examination, okay? So if you don't know this zone, you might commit mistakes in this question. Yes? Understood? Very good. Let us see the next question. Okay, very straightforward question. Please answer this question. Moist soil sample, something is given. Please answer this question. The water content is asked and the dry unit weight is asked. So when it is oven dry, mass is reduced by 50. So this is what? This is your weight of water, because that is what gets evaporated, right? Is the mass reduction. Total was 500. So what is the water content? What is the water content? The weight of solids will be how much? 500 minus 50, giving me how much? 450 gram. So what is the water content? Tell me. What is the water content? Tell me. The water content will be how much? Somebody answered C. Okay. No, C is not the right answer. Please answer the question now. C is not the right answer. Basic formulas, if you are unable to answer, then you know you might commit mistakes. Basic formulas. This is 11.11 because I have to multiply 100. What is your dry unit weight? What is your dry unit weight? Very simple, right? Dry unit weight will be what? Dry unit will be the dry weight or weight of solids divided by total volume. Weight of solids is how much? Your 450 divided by total volume is how much? 0.25 centimeter cube, right? And this is gram. So I can get how much? How much are getting this? Okay, some issues with the values, right? It should be not be 18. I think some 450 gram. I think it should be 25 cc. Okay, this is correction. Okay, 25 cc. Now I'll get the correct answer. 18 gram per centimeter cube. Understood this question? Again, straightforward question. Again, straightforward question. The data was wrong. It was 25 cc. Okay, not 0.25 cc. Okay, so getting the right answer. So again, a basic formula. Again, a basic formula of what? Finding the water content and what? Your dry unit weight. Basic questions which they ask you in such examination. Next question. Okay, fatafat. Okay, relative density. Very good. So relative density we have not revised till now. So a question on relative density. I'll give you the formula. The relative density or the density index is what? The maximum void ratio minus the natural void ratio divided by what? The maximum one minus the minimum one, and this into 100. Answer me this. Now answer. What is asked? See, in dense you will get the minimum one. In loose you will get the maximum one, right? So I can say this is the minimum one and this is the maximum one. Okay. A difference is given. The difference is given. Okay. And maximum one is given how much? 0.8. Solve this question and find out the current void ratio. Current void ratio means what? E. Find out this answer. Come on. Straightforward question. C, D. Why are committing mistakes in this? Huh? What is E minimum? E minimum is not required, right? Directly this difference is given, you can apply that only. That is what? 0.5. So I can say 60% is equal to E max minus E. The difference is given 0.45 into 100. So from here I can say this will be 0.6. How much E you are getting from this? Tell me. Find out the answer. C 0.53. Okay. Okay, 0.53. Yes. Because if you solve this, it is 0.6 into 0.45 will get 0.27. So you'll get 0.8. 0.8 minus E is equal to 0.27. And from here you will get 0.53. Again, you see a basic formula of what? Relative density, which they can ask like this. Okay. Next question. Okay. This question I solved before also, but just I wanted to put so that your concepts are revised again and again. What is the answer of this? What is the answer of this? The ratio of size corresponding to 60% finer and effective size is known as what? C. Very good. You should remember this thing. You see, remember effective size is nothing but D10 and this is D60. The ratio of this is what? This is coefficient of uniformity. It is also the range of size, right? We have discussed before. Also the range of size. Very good. Let us solve another question. Hope you are enjoying this session, okay? So we are coming up with more sessions like this, okay? Don't worry. So this is, starting, okay? So a lot of sessions will conduct like this. Now we are taking, evening GATE lectures, okay? Where we are understanding the concept. You see in GATE what happens, a lot of concept is required to solve numericals. In examination like HPCL or PSUs, okay, you need to remember lot of formulas and lot of straightforward questions. So such sessions will help, okay? Therefore, this is a 50 question session, okay? So today we are taking, then on 21st I will take on consolidation, shear strength and compaction, right? And then on foundation I will take on 23rd. So you should study those topics and come, it will be what? More beneficial. Let us solve the next question. Okay. If the consistency index is negative, soil is in which state? If the consistency index is negative, soil is in which state? Okay. So I'll just write down the formula of consistency index so that you'll get an idea. What is the answer of this? Consistency index is negative. Soil is in which state? Liquid. Deepak has answered liquid. Okay, others? Hanif has answered A. Liquid. Very good. You see, if it is less than 0, that means what? Negative less than 0 means what? This liquid limit is less than water content, or I can say water content is greater than liquid limit. If water content is greater than liquid limit, that means what? Soil is in liquid state. You see, by just knowing the basic formula, you can answer this question, right? Okay, by knowing the basic formula, you can answer this question. Yes, consistency index will come negative when the soil is in what? Your liquid state. Why? The same formula. Yes, consistency index is what? Liquid limit minus the water content divided by IP. Less than 0 means what? Liquid limit is less than that, or I can say natural water content is more than the liquid limit. Understood? Very good. Next question. Okay, little complicated question. Let us see how many are able to solve this question. Little complicated question. Let us see how many are able to solve this question. I'll give you time. We have 9 questions to go and we have 13 minutes. I have planned to make you revise 50 questions in 90 minutes. Okay, that's a good speed, right? Yes. 0 होगा ना क्यों? वो तो लिखा हुआ है कि नेगेटिव है. तो लिखा हुआ है नेगेटिव है, तो 0 क्यों होगा? वो लिखा हुआ है नेगेटिव मतलब नेगेटिव है. See, plasticity index cannot be 0, but consistency index and liquid index can be, plasticity index cannot less than 0. IP is always greater than or equal to 0. But your consistency index or liquid index, they can be less than 0. They can be less than 0. Okay. So in plasticity index, if you are getting negative value, then you will take that as 0. But not in the case of IC or IL. That is negative means you take it negative. Okay. Okay. Now the answer. Out of 500 answer, okay, C. Some people answered C. Okay, this answer. Okay, it's a very tough question. Not a very tough, but let's solve this question. You see, this is 4.75 mm strip, and this is how much? This is 75 micron strip. Okay, micrometer. Now you see, below 75, 150 passed. Very good. Now see, below 4.75, 400 passed. So how many are between the size 4.75 and 75? How many are in the size 4.75 and 75 micron? How much is between the sizes 4.75 and 75 micron? 250 gram. So here 250 gram. Okay, here 250, here 150, and now see total is 500. So how much above 4.75? 100. Now tell me, this is what? This is what? Tell me. This is gravel or sand, or it is fine grained? Tell me. It is gravel or sand or fine grained? Then judge by what? By just seeing the amount of what? Particles, the weight of particles. It is gravel, it is sand. You see, maximum one is sand. So this is what? Sand. So this is sand. First thing, this is sand. So in sand we have two options, well graded or clay. Now how to choose? You see, this is the fine grained, right? Now what is the percentage of fine grained? The percentage of fine grained is what? How much it is coming? The percentage of fine grained is coming how much? Your 30%, right? The percentage of fine grained, fines percentage is what? 30%. When the fines percent is 30% means what? Greater than 12%. And we know when the fines is greater than 12, when the fines is greater than 12, that means what? Either it will be SM, silty sand, or it will be SC, right? So your SC is given, SM is not given. That means what? This is a right answer. This is right answer. Understood? Tricky question, but understood. Now see, just for fun, if I tell fines is less than 5%, then it would have been what? Then it would have been what? SW or SP, right? Right? When the fines is less than percentage, either it will be well graded or poorly graded, depending on different other parameters. And if it is greater than 12%, then it will be either silty or clay based on different parameters. But here only one option is given, therefore SC is the right answer. You see, you need to be smart to answer these questions. Next question. Okay, find out the shrinkage limit. Finding out the shrinkage limit. So towards the end of the slide, we can say that we are solving some good questions also. Okay, because see, every question will not be very straightforward. Some straightforward questions we also solved. Some good question also will solve. I'll solve this question for you. Don't worry. So they ask you shrinkage limit like this. You see what to do. You first draw this graph between what volume and your water content. You see, at liquid limit of 50, the volume is 100. The volume is what? 100, right? Then at plastic limit of 32, the volume is what? The volume is 76. The volume is 76. At dry volume is 48. And we know that the volume don't change from dry condition to shrinkage limit. So at shrinkage limit also it is 48. Now what we can do? We can use that the slope is same in both the parts. This slope and this slope, right? So we can equate this both the slopes, right? Suppose slope 1 and slope 2. Slope 1 will be how much? It will be 100 minus 76 by 50 minus 32. Y2 minus Y1 by X2 minus X1. Slope, right? And that will be equal to the slope here what? In the second part it is what? 76 minus 48 divided by 32 minus shrinkage limit. So from here you can easily find out shrinkage limit. Very straightforward question. This is 24 by 18 is equal to, this one is 28, right? Yeah, by this. So this is, I can say, this is 7, this is 6, this is 3, this is 11. So WSH will be equal to 21. So 32 minus 21. You're getting 11, right? Getting 11? Understood this question? So they can ask a question like this. Now tell me if you understood the concept, you can solve this question within 1 minute now. Within less than 1 minute also you can solve this question. And this question they can ask in GATE also. They can ask in GATE also. Next question. Okay, little good question. Let us see how many are able to solve this question. So towards the end, some good questions we have put. Okay, because in the examination they might ask you some good questions also. So both short question also good. Every question is good only. We can say straightforward and little bit. You see, number of flow lines is given and number of potential lines is given. You see, flow lines is not equal to the flow channels. The number of flow channels is what? Number of flow lines minus 1. Remember this, right? And the number of potential drops will be equal to what? The number of equipotential lines minus 1. That is what? 16. So NF and ND we found out, right? The head difference is 3.5. The coefficient of permeability is this. Seepage we have to find. That is very easy, right? In meter cube per second. Very easy. The formula is what? NF by ND into H into K. Now this is your seepage. Now what was the catch here? The catch is here that these flow lines you cannot take as flow channels. Don't forget to subtract 1. This is 8 by 16 into what? 3.5 into 4 into 10 to the power minus 3. So this is 2, this is 2. I am getting how much? 7 into 10 to the power minus 3. Okay. See, why some error I have done? No, it is 7, right? 7.41 how we are getting? Seven, na? Okay, correct. Next question. Why not able to answer this question so fast? You should be able to answer this question fast. Okay. Okay. Next question. Okay, answer this very straightforward theoretical question. Very straightforward theoretical question. Please answer this. Very straightforward theoretical question. So more 6 to go. It is applicable for, very important, all the type of flow. Darcy's law is applicable when the flow is continuous, steady and laminar. All the three conditions are important. Remember this condition, okay? They might ask you a question. What was Darcy's law? Darcy's law was, yesterday we saw in our gate class, KIA. Okay, let us solve the next question, 46th question. In parallel flow across soil layers. Okay, let us answer this question. In parallel flow across soil layers. Okay, parallel flow means when the flow is happening parallel to the surfaces, or you can say layers. Okay, what is same and what is different? Answer is D. Yes, you see the cross sections are different. You see, this is different cross section, also different cross section. For different layers, the cross section is different. So area is not same. The head difference is same because if you have a piezometer here or here, okay, you will get the same head difference. So head difference is same and the drainage path is same. So what will happen? Your hydraulic gradient, head difference and your drainage path all are same. So answer is B and C. You see? Next question. Okay, very straightforward question. Constant head permeability test is applicable to constant test. Constant test, nahi, constant head. Okay, my health is little weak. Okay, so I took medicine and came to the class. Okay, you can see from my eyes also, they are little, small now because I had fever also and cold. So I took medicine and came, so mind is little tired. Okay, so constant head permeability is applicable to coarse grained soil. Remember this, right? Because it is not applicable to fine grained. Why? Because fine grained soil has very low K and you cannot collect lot of water in a very short time, like long time. So for fine grained we have what? Falling head test. Remember this. For this fine grained we have falling head test. For coarse grained we have constant head test. Okay, next question. 48. Very good. Please solve this question. 48. The ratio of head difference and drainage path. Very straightforward question. Fast. Very straightforward question. Fast. To tell me the answer. The ratio of head difference and the drainage path. H by L is what? Your hydraulic gradient. Okay. So you are seeing that we have mixture of questions, right? Some questions we have little tricky, some questions numerical based, concept based, some straightforward. You see that type of question you can expect in HPCL and in your PSU examination or your SSC JEE prelims. Okay. Next question. Safe factor for flow net is what? I told just time before only. Safe factor is what? Safe factor in flow net diagram is what? Safe factor for flow net diagram is what? Tell me. Very straightforward question. See, it is NF by ND. NF by ND is the safe factor. Now coming to the last question. Very tricky question. Let us see who is able to answer this question. Discharge velocity under unit hydraulic gradient. Unit hydraulic gradient means what? I is equal to 1 is known as what? Tell me. I is equal to 1 is known as what? Tell me. So 50 questions we were able to solve in 90 minutes and we didn't only solve, we discussed also. We saw that what are different type of questions they can ask. Okay. So coefficient of permeability. It is coefficient of permeability. You see B is equal to what? See, Q is equal to KIA. This is what? This is your Darcy's law. So Q by A, that is equal to your discharge velocity will be what? Ki. So if I is 1, then the discharge velocity is equal to what? Is equal to what? The coefficient of permeability. Okay. So we solved 50 questions. Okay. Initially I told that we will be solving 50 questions And from which topics we solved? If you remember, we solved from these topics. You see, basic properties. Yes, we solved from your basic properties, index properties, classification of soil, effective stress, permeability and seepage. So, hope this particular session helped you a lot. Okay, hope this particular session helped you a lot. You can, attend more such lectures. So, as I told, today we completed the soil mechanics. On 21st, means what? Day after tomorrow, at 11 a.m. only. This is 11 a.m. lectures. Okay, we'll be covering consolidation, compaction and shear strength. So I can request that you complete your consolidation, compaction and shear strength test. Okay, and consolidation also I have taken YouTube lectures in this particular YouTube channel also. You can refer to them also. Okay, and then today evening. Okay, so this was for your HPCL and other state exams and all. In today evening at 6 p.m. Okay, today at 6 p.m. we'll be studying what? Your active earth pressure in cohesion-less soil. Okay, so please attend this session. This will be for your GATE concept series, GATE and SSC and ESC. Okay, I can say mostly what? Even you see some objectives can also be asked, right? Okay, so we will solve objectives, we will solve numericals, everything. Okay, in active earth pressure in cohesion-less soil. So this is at 6 p.m. Okay, at 6 p.m. and the HPCL series will be at 11 a.m. But HPCL will be on alternate days. Okay, so thank you very much. Okay, so we'll meet every one of us will meet at 6 p.m. today. So please attend the lecture at 6 p.m. today. We'll be studying what? Your active earth pressure in cohesion-less soil. Thank you very much. This is my phone number. If anybody has any doubt, any concern, they can directly contact me. I will answer the query. Thank you.